In this video, we're going to multiply various monomials by other monomials. Now recall that a monomial is simply a polynomial with one term. So we're going to have one-term monomials multiplied by other one-term monomials. Simplifying these will involve using both the associative and commutative properties of multiplication, as well as the rules of exponents. So let's look at the first one. We have 3x times negative 7x. Now, in terms of this multiplication, we can realize that this is actually 3 times x times the number negative 7 times x again. And the process that we'll do formally is that we can then switch the order in which we're multiplying that first x and negative 7 and make this 3 times negative 7 times x times x. Now, 3 times negative 7 is negative 21, and x times x is simply x squared. So that expression simplifies to negative 21x squared. That process where we formally rewrote the x and negative 7 in reverse order using the commutative property of multiplication, that's one we'll oftentimes do in our head, but it's important to see how it works so that we can keep track of what properties are being applied. Let's come to this next one. We have negative 8/3 t times the expression negative 3/5 t squared. So as we look at this, I will have, and again I'll group this, I'll have negative 8/3 times t times negative 3/5 times t squared. Now I want to multiply the coefficients, so I'm going to write each of those first, and again I can do that by that commutative property of multiplication. So I'll have negative 8/3 times negative 3/5 times t squared. Now when I take negative 8/3 times negative 3/5, a negative times a negative becomes a positive times a positive. So I can think of that as 8 times 3 over 3 times 5. Again, I've switched those to positives since I have two negatives that I'm multiplying. And then I have times t, and I have t to the 1 times t to the second. So that's t to the 1 plus 2 if I'm formally using those properties of exponent rules. So let's simplify this. 8 times 3 over 3 times 5, that's just 8/5. Those 3's would cancel, so I have 8/5. And then t cubed. That exponent on t is now 3. Looking at our next example, we have 4p squared times p to the 5th. And so as we look at this, this is 4 times p squared times p to the 5th. And so all we really need to do here is look at, I have p squared and p to the 5th. Total, I will have p to the 7th. So I will have 4p to the 7th power. Again, looking at that 4, I just had one single factor of 4. So I had 4 times p squared times p to the 5th. All that I had to do there was use the property of exponent rules that turns p to the 2nd times p to the 5th into p to the 7th. For our last example, we have negative 9q squared times 10q cubed. So first thing we want to do, let's group negative 9 and 10. So negative 9 times 10 times q squared times q to the 3rd. And so negative 9 times 10 gives us negative 90, and q squared times q cubed, we add those exponents and we get q to the 5th. So that expression will simplify to negative 90 q to the 5th.